5, 6, 7,
Guys,
8.
we're on air.
Okay, now they can hear.
Yeah. Subscribe.
Whew. All right, circles. Okay. This word always throws people off. Locust, not locust with a T, like the insect.
It's like
Locust. This just means the set of points. Okay, so it's just a set of points that are equidistant from a given point called the center. Okay, so imagine, right, here's our center. So if I were to put all the points, right, kept going, that are equidistant, and kept going all of the points, infinitely many, that would create a circle. Okay. Specifically, we say in a plane, so it's a flat surface, because if it wasn't in a plane, instead of a circle, we would have, what would we have?
A sphere. Wait, but doesn't that real circle not actually exist then? It's like it's a bunch. It's like really big.
Which one?
It's a really big like. What's it called?
But a locus is a set of points.
The locus is a set of points. But if it wasn't 2-dimensional and it was 3-dimensional,
So
it would be a
really
sphere.
polygon.
Yeah.
Brian said Brian.
Yeah, you said sphere. Okay.
Thank you.
It is. It's named by its center point. So we, just like with triangles, we put a little triangle symbol. With circles, we put a little circle and we put a dot inside so it doesn't look like the letter O. Just so it looks, that's our notation for circle. Okay, I'm hoping some of this terminology is familiar because we already talked about it in this class. The radius is the segment with endpoints at the center and on the circle. So think like halfway across. Remember, we use radius when we're doing area and circumference. This one might be new. This is a segment with endpoints on the circle. Okay, so it just goes from one end to the other.
Can it be anywhere?
So a diameter could be a chord,
Anywhere.
right? A diameter
So it could be like really short because it's on the top. A diameter
wait,
is always
okay,
a
so-
chord.
A
Okay,
diameter could be is always a chord.
right. So we'll look at the definition.
Oh, a chord.
A chord that passes through the center.
Oh,
Right.
So, chord is a diameter, but
So-
a diameter.
A diameter is a chord always. But if I
Oh my
said
God,
it's
you're
a
gonna
chord,
do one of those. And it's gonna...
if I said a chord is a diameter,
Sometimes. But is a diameter a chord? Always. Okay, that's actually the easiest.
okay, these are probably
What's a chord?
new. Secant is a line that intersects a circle at 2 points. Okay, so if we took a chord and extended it, it would be a secant, right? Because, right, here's a chord and here's a chord. But if we extended it, it turns it into a line. And lastly, we have a tangent. This is a, so it's not the same as sine, cosine, tangent.
Okay.
What?
So tangent
It's
here.
just a different tangent.
This is a different tangent.
Tangent.
This a tangent line intersects a circle at exactly 1 point. So if you've ever heard of someone going off on a tangent, right? You've never heard that term?
No, I've heard that.
Are they going off Earth? They're leaving Earth.
I've heard that.
There we go. So we call this the point of tangency.
Oh, great.
Wait, it's like
Wait.
Okay.
So the credit tangency has to be like the end, like the outside of the circle.
It's yeah. So a tangent line cannot go through the circle. Okay? The tangent line has to go on the outside.
Bro, this is too easy.
All right, let's take a look. Okay. Name the circles. So we're going to put a little
C.
circle symbol with the letter C. Okay, how about we do this?
BD.
Instead of calling out, because we're recording and that can get very frustrating when you're watching it, we're going to raise our hands and volunteer.
BD. We're doing for radius?
Radius.
For radius? Alright, for radius, give me AC.
AC.
CD? What the heck is
It's the
CD?
same exact thing as AC.
Okay.
What?
Is also an option. What we want to make sure is that we put the little line above because it is a segment. Okay?
Oh, we don't do the circle on that one.
No, so only the circle gets the little symbol with the circle. Okay, raise your hand for C. Chord, Sophia. BD.
Wait, what's a chord again?
Just the line.
Just the line.
It's just this. Oh, careful! It's
2
a
points.
segment that has 2 points on the circle.
Wait,
Okay.
diameter could be a chord. But a chord isn't always a diameter.
Okay, Shelby.
The diameter is AD.
Good. AD. Okay, the next two are lines, whereas these three were all segments. So, Aaron, you got a secant?
Wait, what's the difference between a secant and a chord?
You want to do a secant?
Yeah, what's a secant?
Oh, wait, BD.
B.
Wait,
D?
but what's
Segment,
the
second BD.
difference?
So a secant.
Oh, because it
Wait, Miss
continues
Kate,
outside of
can I
the
come up and
circle.
can I come up and explain? Can I come up and explain?
Oh, a secant like continue.
The secant continues. So,
it
a
could also
chord.
be this.
A chord is basically part of the secant line. Okay, so the chord is the segment, it stops.
It ends on
But the
side.
secant keeps going. It's a line. Yeah, look.
And then for G,
Uh-huh.
it's line EA.
Perfect.
And E.
Okay, it doesn't matter. They're the same thing.
EA is crazy.
A sounds
Boring. Isn't like that.
Shut up.
All right, so circle A has diameters DF and PG. So that means, right, this going all the way across and this going all the way across, those are diameters. Okay, so if DF is 10,
PD. PG would also be 10.
DA,
It's 5.
What in the world? It's just like
Okay.
The radius is like half of the. That's all you see.
yeah, so DF is a diameter, so DA is half of it, which is, okay, AG
24.
is 12, LA,
12. 12.
What? Oh.
Yeah.
Wait, are they cool?
well, remember the radius, all we say the plural radius is radii. They're all congruent, because remember, didn't we say the circle is equidistant from the center? So all of these segments, all 4 of these or 5 of these segments are all congruent to each other. They have to be, because the circle is equidistant. It's not an oval where one is going to be shorter than the other. Okay, diameters of circle A, circle B, and circle C are 10 inches, 20 inches, and 14 inches respectively. Respectively means in the order they were named. So for example, circle A is 10 inches, circle B is 20 inches, and C is 14 inches. Okay. Now we want to find XB and we want to find BY. You got an idea, Ryan?
Yes, so which should I say the answer? Or
What's your
to
approach
label
here?
it, to label it?
Yeah,
So
what?
AX, we know is going to be 10.
Good.
And then AB would be 20 minus 10. So XB is 10.
Wait, you have
We don't have to read it. That's the radius.
5, yeah.
No, you guys are not thinking. Look.
Yeah, that's what I said.
Right, it's the radius. That's the diameter.
Ryan, you're actually.
All the way across is 10. So from A to X is 5. Circle B has a diameter of 20.
You're really confident with that.
Yeah.
I'm not gonna lie, you had a lot of confidence in the answer. No, don't cry, so
Okay.
Thank you for all. I guess get back.
Wait, how do we know x is 5?
So if this is 5 and this whole thing is 10, because that radius has to be 10, what's left over is 5.
No.
Okay.
That's what 5 is 5.
All right, Hannah.
Okay, so you know that the diameter of circle C is 14, so you know that CY is 7.
Oh, yeah, you're right. Sorry. I almost labeled that wrong.
And you know that the diameter of B is 20, so it has to be 8 because like total in the like okay, so XB plus BY has to be 8 because
Last week's
no because
DC is
no.
10.
3.
Yes.
No, it's 3 and 5.
Yeah, this is
Total,
going to be
that's
3.
10. Then total, that's 8.
If all the way across is from here to here is 10 and this is 7.
It's 7.49.
BY.
No, 8 total.
Wait, I have a question.
Where's the-
How is it 7?
Okay, okay,
I
guys.
thought-
No, I'll let Hannah look.
Yeah,
That's not what I thought.
Okay. All right, Ness, you had a question.
Is the 10 from A to B?
Yeah, 10 is from A to B here, and from B to C it's 10.
So how do we know that B is 1?
Well, because this is
I
7.
need to go back.
So what's left over? Okay.
7 plus 3 is 10.
Okay, just a quick reminder. Circumference is the distance around the circle. Okay. We can use pi times diameter, or we can use 2 times pi times r. Doesn't matter, they're the same thing. What I want you to do, though, is we're going to practice writing in exact form and also rounded to the 10th. When I say exact form, this is going to be where we're going to leave pi in the answer. Okay, so I want to find the circumference. If the radius is 7, so that's going to be 2 times pi times 7, which will be 14 centimeters. So this is our exact form. Oh, thank you. Yeah, it's supposed to have a pi there. There we go. Okay. And on the calculator, pi is all the way down on the left. If you click it, you're going to select pi.
What's 14 times
Okay, so I get
Yeah, actually, I'll do that later.
43.98.
You multiply
44.
Wait, I tried exact.
Probably just
Or do I try exact?
Yeah, this is going to give me
Watch
error.
your squiggly
It'd be like this.
Okay. Okay, so our exact answer.
It's not gonna be that.
To infinity and error. Not smart enough.
Okay. 14 pi is our exact answer. You don't have to put the squiggly lines. The squiggly lines is when you put it in your calculator and you get a decimal approximation. This is a rounded answer. It's not exact. Okay, what about the next one? If we find C, it's going to be just 12.5 pi inches, because pi times diameter. And we also want to find the exact one, so that's going to be 12.5. Don't use 3.14. Please use the pi button on the calculator. Okay, it's down here, and we select that. So this is going to be 39.3. Sometimes it'll give you the same answer, but because 3.14 is an approximation, it could give you an answer that's wrong, like off. Okay. All right, now what if we want to work backwards? What if we have circumference?
20 equals pi. Or you could do 20 equals 2 pi r.
Yep, I would like 20.
Is it not just like 10?
So it's 20 divided by 2 pi.
Okay, so I'm going to divide by 2 pi. Now I just want to be careful. What's the matter? So I'm going to take 20 and I want to divide by 2 pi. Just be careful if I try to type it in 20 divided by 2 pi like this. What's going to happen when I press enter? It's going to do 20 divided by 2 and then times pi. So you can do control divide. Right? You see those are two very different answers. Or you can do 20 and then you can put in parentheses 2 pi. I actually think it's much easier just to press control divide. Control divide just makes your fraction line for you. All right. Okay, so what was that? That was 3.2. And meters. I noticed I didn't take off points on the test if you didn't have the right units. When we get to our area and our surface area and volume chapter, we're going to have to include them. Just FYI, I've been generous with not taking off any points, but it's going to come up where if you don't have the correct units.
Like half the question.
No, I won't take off half the question.
Let me see the weight circumference equals 2 times
Okay.
radius. 2 pi times radius.
If there's no like on the bonus, like there wasn't any.
You can
I just
either-
throw like units squared.
That's fine. You can either leave it blank or you can put units squared. If there's no units provided, I'm not going to take off points. But if I give you something in meters, right, I want to have it in meters or square meters. Okay, then we have a polygon is inscribed. Inscribed means all the vertices are on the circle. So here, 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 and here. Okay. So let's see. Example 6. A square is inscribed in a circle with a radius 2. I'm going to find the area of the square. No, this was just a quadrilateral. This was just, I wanted to give you the definition of inscribed. Good? Right? Inside the circle. Okay, so let's make a circle. Yes, we're going to be drawing lots of circles here. Doesn't have to be perfect. It's okay. Mine's not. Now I want to put a square inside of the circle.
Is it inscribed?
So we're going to put inscribed. Just think inscribed is inside. Okay, use your imagination. Not the best part is. Okay. Oh.
We just drew a circle with a square to the left.
All right, we want to draw. Okay, so I know the radius is 2. So here's what I'm going to do. I'm going to draw the diagonal, or I'm going to draw the radius here.
Why? Then we'll hit like the corner of the
Okay.
Oh, it has to be
Well, listen, does it make sense to draw the radius this way?
No.
No. So that's why I draw it to the vertex.
Oh, is that like part of that diagonal? So the diagonal is before?
The diagonal all the way across would be 4 total.
Oh my god. Is it like the 45? Oh,
So this is a 45, 45, 90. So if the hypotenuse is 4, then each side is going to be 2 root 2.
Wait, do you mean 45? Why did you?
Yeah, I drew it.
Sorry, 45. Okay.
Wow.
Okay. Wasn't that?
We're so excited.
Wait, no, I'm not.
Are we good? Because we take the hypotenuse and divide by root 2.
So it's
So area.
Wait, how do we figure out the hypotenuse?
Because if the radius is 2, all the way across has to be 4. And then each.
Wait, so this is 4 over root 2, which just equals to 2 root 2.
Right? Equals 8 square centimeters. Area is always square units. Perimeter and radius. Circumference, those are just plain units. But area is always square units. Perimeter is just plain centimeters. All right. Here we have a picture already given to us. We want to find the diameter and the circumference given. Well, this is a radius and this is a radius, so we know they have to be congruent. So again, what kind of triangle do we have? This is a 45, 45, 90. So we have to divide by square root of 2, which fortunately works out nicely. So that means my radius is 3. So that makes my diameter 6.
So 6 pi.
And what's my circumference? 6 pi. We'll just leave it.
How will we know if you want it in that form?
I'll tell you.
What's radius squared?
That is area.
Well, that's in
Pi r squared is area.
circumference is just.
Okay, find the exact circumference of the circle. Well,
Now the circle's in the
Oh.
square.
if this is 9, this is 9. Right? It's just showing, so the circle is inside of a square.
Inscribe the circle.
And this is just millimeters.
Sorry, that was not
If it's an exact, it's gonna be
That's exact.
That is exact. Okay,
It was
exact
rounded
is
to plug
with
it
the
in.
pi.
even on purpose. It was just a reflex.
Oh, SAT.
Oh, I threw in a couple of PSAT questions.
Oh,
Let-
hold on.
Okay, while I'm getting your homework ready, why don't we try? You guys can try
Still
these.
not done.
Oh, these are fast.
Oh, wait, can you go up like a little bit?
Oh, no.
5. Yeah, okay, we're good. I don't need it.
Okay, let's see if we can get these 2 PSAT. Yeah. What do we think?
Wait, what if I don't want? Wait, is this happening? What? Wait, do you want to do that?
Well, yeah.
What? What
Oh, yeah,
PSAT
you
is
guys
it?
You guys are all going to take the PSAT.
This is
in
like the
10th and
actual
11th grade.
PSA, like, do these questions would be on the 10th grade?
So I just did practice ones.
Why is the worksheet?
I don't remember how to do.
It looks different
From the book.
Oh, it's
I didn't
C.
make it.
So it is. It's like a book.
Guys, it's C.
It's bookwork in disguise.
How do I know?
How do we know which one is it?
It's B.
It's C.
It's C, Shelby.
Then I guess it's sorry, guys.
Because you just tried a bunch of times.
Gosh, Shelby.
Oh, you actually just plugged in numbers?
Yeah.
Oh, I just did like 2 times 1 plus 2 is
I mean, you
4,
can
2
get
times
slow.
2.
Slope would be 6 minus 4.
Oh yeah, or that, you can do that.
So I know it can't
Oh,
be
I
that
did it
one.
upside down.
I was gonna guess, I guess.
But if you want to find the equation,
How'd you get that?
what's that?
Oh wait, no.
So it should be C. All right. And then the last part, x minus 3 is less than 9, y plus 1 is less than 4. What is a possible solution for x plus y? So let's see. If I solve for x in this one, x has to be less than 12. And y has to be less than 3. So x plus y has to be less than 12 plus 3, right?
So,
Yeah, which one of these answers? Oh, sorry, that was supposed to be 15. Which one of these is less than 15? D.